Hey guys, so we are in my living room right now. That's why the lighting is horrible, and I apologize for that, but the lighting won't last long. This intro clip is just to show you this device working. This device right here is something I like to call the keyminder. It's the project we're going to be building in this video. And it's a device that reminds you to put up your keys when you get home by sounding an alarm when you open your door. And the only way to turn off the alarm is to plug your key into this 1/4-inch female jack with a male jack that'll be mounted on your key ring. So the only way to turn off the alarm is to plug it in. That way you know where your keys are. The idea behind this is quite simple. You just want to basically keep track of your keys, because if you're like me, the last thought you have on your mind when you get home is to put your keys up somewhere you're not gonna forget. Because basically when I get home from work, my keys are lost as soon as I open the door. I have a key hook and I don't put it on there. So this idea is to hopefully force me to put my key up, so that way I know where it is all the time, so I'm not looking for it last minute. So let me show you how it works, and then we're going to build it. So right here we have a magnet. Once this magnet moves away from this reed switch that is just temporarily mounted this way, it'll clock the input of this chip to shift to this red LED, which also send a signal to a NPN transistor, which will turn on this little alarm circuit right here. And the only way to disable the alarm circuit is by plugging in your keys to this jack right here, which actually pulls the base of a PNP transistor high, which turns off the flow of current to the alarm circuit. So let's test it out. We're just going to open the door, the alarm will sound, and then I will plug my key into it. So let's close the door. And there we go, the alarm is off and you know where your keys are, which is really cool. I have to mount this a little bit better. This was just temporary. But yeah, let's go ahead and build this circuit. So this is the circuit behind keyminder. It's really simple. I'll explain parts of it now and the rest of it throughout this video. Right now I just want to show you, or rather explain to you, how this will work and then how we'll interface it to our keys. The heart of this circuit uses a 4017 decade counter. The decade counter has 10 outputs, hence the name decade, and a clock input. The clock input turns on and off the outputs. And we'll be using 2 of those to interface our alarm and our keys. Right here we have a switch. This will actually be replaced with a 1/4-inch female jack, and the switching of it will be determined based on whether or not a male 1/4-inch plug is plugged into that. When it's plugged in, the switch will be closed, and when it's unplugged, it'll be open. Over here we have a tactile switch and a reed switch. So I'm going to walk you through how this will work, and then we'll breadboard it, and then we'll actually solder it up and mount it on our wall. So how we're going to interface this device to our door is actually really simple. We're going to be using what's called a reed switch. For those of you who don't know, a reed switch is a switch that opens and closes based on the proximity of a magnet, which is this guy right here. So we'll mount a magnet on our door, and we'll mount the reed switch near the door, so that way when the door opens, the magnet moves away from it. So let me put you in a hypothetical situation right now, and I'll explain to you how the circuit works along the way. So let's say you got home from work, you unlock your door, and you open your door. When you open your door, the magnet will move away from the reed switch, causing it to open up, which will disconnect it from VCC or 5 volts, and it will then no longer have any current going through it or to this transistor right here. So the base of this transistor will now go to ground by default, which will pull it low, which will then turn on this transistor, which will then send a high signal to the clock input of the 4017 decade counter, which will then shift its output from this guy right here to this guy, Q0. So now Q0 will actually have a high output, which will turn on this LED, send current through this resistor to the base of this transistor, which will then ground the piezo speaker or hacked door alarm in my case, which I'll explain later on, which will allow it to turn on and start screaming at you. Now up here you see another PNP transistor. This over here is how you will basically turn it off using your keys. So as I explained earlier, this will be a 1/4-inch female jack, and the male jack will be on your keychain or something, and when you plug that male jack in, it'll actually close this, acting as a switch. So how this works over here is when the base of this PNP transistor is low, current will flow through it, which will then allow for the piezo speaker to have a supply voltage, which will cause it to turn on and scream at you until you address it. So when you get home, you hear the alarm going off, you take your keys and you plug it into this jack right here, which will allow for this to close to this, which will have a 5 volts, which is VCC, a 5 volt signal going through it, through this resistor right here to the base of this transistor, thus turning it off, which cuts off its supply voltage to the piezo speaker, which basically just turns off the piezo speaker. So now you plugged in your keys and the alarm is off, but you know where your keys are because they're plugged in. So now, let's just say you got home, you plugged in your key, and now you want to go somewhere else. So you unplug your key and the alarm starts going off. So how do you address that? You don't want to plug in your key and leave it there. That's what this switch over here is for. As you can see, it's in parallel with this reed switch. You simply just press it and it'll connect the base of this transistor to 5 volts or VCC, which will shift the output of the decade counter again to just this LED right here instead of the screaming piezo speaker. Let me just zoom in right now. So now only this LED will be on, which we can label as a going out LED. So that way the alarm isn't screaming and alerting your neighbors or anything like that, because you don't want that. And once you press that button and the door closes this reed switch, the cycle will start all over again as soon as you open the door. And it's a really neat idea, so that way when you get home from work or whatever, you don't just put your keys wherever you're walking, which is what I'm guilty of every day. And you won't be in a panic looking for them when you have to leave the next day or something like that, which happens to me quite often and I can't stand it. So I guess you can kind of take advantage of this if you wanted to. Say, for example, you get home from work and you don't want to plug in your key, just push this button. But that's on you, because this device basically is just to alert you to tell you that you should plug your key in to it so that way you know where it is. So now we're just going to go ahead and move over to the breadboard, and we're going to breadboard this circuit and give you a better understanding of how it works. And then we're going to build it and mount it near my door. So let's get. I picked up this right here for $1. It's a window and door alarm. It just turns on an alarm when you move the magnet away from the reed switch. The reason why I picked this up is because it's $1. It has a reed switch and a magnet, which I need for my circuit, and it also has a speaker that has its own driver. So it has a few things already on it that I can use. You don't necessarily need this exactly to build this circuit. You can use anything else. I just picked this up because it avoids some stuff, and it also has a reed switch on it, which I need. I could use this reed switch right here, but it's a single pull double throw, and I don't want to use it for that. It's a fun one. I don't want to use it for this project, so we're just going to be using this instead. So let's go ahead and take this apart, and then we're going to solder it up to some adapters and put it on my breadboard. So this right here just comes off. So now, oh, it's already turned on, so let's go ahead and turn that off. So we're going to unplug this little tab. We have a magnet right here. So when the magnet is next to it, you don't hear anything, but when I move it away, it screams. And that we want that speaker, we want that noise to alert us. So let's go ahead and get those batteries out of there and take it apart. I see no screws to it, which is weird. Yeah, I don't know how you take it apart then if there's no screws. It probably just snaps open. Let's see. Okay, it just pops right off. I picked up 2 of these. I'm not too sure which one I'm going to end up using, because I might keep this one in its case or whatnot. But there's the insides of it. We have a reed switch right there, which we'll go ahead and snip out and use for our project. And yeah, we have the speaker right here. So let's go ahead and hook this up to my breadboard along with the other parts of the circuit and get building it. Okay, so I have the circuit hooked up on my breadboard. I have a 5-volt supply connected to my variable bench power supply. And as you can see, we have a green LED and a whole bunch of stuff. This right here is the door alarm that I just showed you. It's actually a different one that I hacked up. We have the reed switch floating right here and a little tactile switch right over here that we're just going to use to turn it on and off. Right here is the 1/4-inch female plug, and right here is a male plug that I just shorted out. So right now the tip and barrel are connected together, and it'll actually close this circuit right here. And that's how we're actually going to interface this. This will be mounted on my keychain. Then I'll just plug it in there, and my keys will be in one spot, and this alarm will turn off. So let's just kind of walk through how this works. So let me go ahead and find the magnet. So here's the magnet. It came in this little white package. It's floating around in there. So let's say right now this is in what I'm going to be calling going out mode. Basically, when you leave your house, you don't want the alarm going off, so you just push the button and shift its output. So let's turn it on real quick. So right there, the alarm's going off. So let's say you just unplug your keys and you want to turn the alarm off. You just push the button, and that basically just sends it in a mode where the alarm's off, and you're just, going out. So let's say you're leaving home and going to work, and you just deactivated the alarm because you don't want it going off all day. So when you close the door, the magnet goes towards the reed switch. So now the reed switch is closed, which has current going to the base of a transistor. So now let's say 8 hours pass, you come home, you open the door, the magnet will move away from the reed switch, and will then turn on the alarm. So now you have to go ahead and take out your keys and plug the male into the female, turning off the alarm. Pretty cool. So now let's say you want to go out again. Take your keys. You don't want to hear the alarm, so you push the going out button, and it puts it in a standby mode, and the door closes, and now you just repeat over and over again. So now you know where your keys are at all times, which is the focus point behind this project. So let's go ahead and solder this circuit up to a breadboard. I will probably replace this little switch right here with this momentary toggle switch. So let's go ahead and solder this up. Okay, so the circuit's all soldered up onto this piece of perf board. We have our 1/4 inch male plugged into the 1/4 inch female, magnet right here. So let's test it out. So let's say you're leaving the house. So you unplug your keys. The alarm goes off. You push the going out button, and the door closes behind you. So now when you come home, you open the door, it shifts to red, and you plug your keys in. And now you know where your keys are. So let's go ahead and mount this. So I have the device mounted on a piece of wood that is just double-sided taped to my wall right here next to the door frame, and I'm just going to peel it off later on and move it because this is not where I want it. This just has the best lighting, unfortunately, outside of my workroom. So sorry for the poor lighting, but we have the magnet right here, the reed switch right here, and the circuit right here, and a power cable supplying 5 volts to the circuit running to an outlet below. So let's see if it works. Alright, so let's just say we got home from work. It's in standby mode right now. So we get home from work, we open the door after unlocking it. The alarm sounds. And the only way to turn off the alarm is by plugging in your key. There we go. And now let's say we want to go to the store or something. So we leave, the alarm is deactivated, and we just take our keys, and we're good to go. Maybe there's a way to make an alarm in the future that'll remind you to take your keys, that way you don't lock your door and leave your keys in the house. I don't do that. I mainly just leave my keys wherever I come into the house, and I have no idea where I put them, so I end up losing them. So this is what this device is for, just to kind of prevent that. I also realized that since this magnet is on this reed switch at all times, it kind of makes this manual clock button that I added pointless, because you can just use the door to clock the input. But the button's a nice touch anyways, just in case we need it for whatever reason. It's a nice feature to have. But the magnet does pretty much everything, so that is cool. So thank you guys so much for watching. If you like this video, feel free to leave a comment below with suggestions or criticism, anything really. And also feel free to subscribe for more videos like this in the future. Thank you so much for watching. I'll see you next time.